Good morning students. Continue the discussion. Today is also continue the some properties of determinant. Yesterday is also discussed some 6 properties of determinants. Today's 2 properties are will be there, but we'll recall the yesterday's properties. What are will be proved in their yesterday classes. First we'll recall the statements. Just will only the statements of that properties. Now first one is the value of determinant is does not altered when all the elements of rows and columns are interchanged. So if all the elements of rows and columns are also called as transpose of the matrix. So if all the transpose of the determinants are does not altered, that is denoted by determinant of A is equal to determinant of A dash. So A dash is nothing but transpose of A. So therefore all the elements of rows and columns are interchanged, then the values of the determinants are does not altered. But in your proof it's also can be written as delta is equal to delta 1. So second property is if any 2 rows or any 2 columns are interchanged, then the values of the determinants is changes with their sign. Any 2 rows or any 2 columns are interchanged, then their values are will be changes with their positive and negative. Third one. So the values of the determinant is 0 if all the elements of any 2 rows or any 2 columns are identical. The elements of any 2 row or any 2 columns are identical, then the values of the determinant is 0. Now fourth one is again values of the determinant is 0 if all the elements of any row or any column is 0. If all the elements of any row or any column is 0, then the values of the determinant is also 0. Then fifth one, if all the elements of any row or any columns is multiplied by some scalar number, non-zero scalar number k, then the whole determinant is multiplied by k. That is defined by delta 1 is equal to k times of delta. So if all the elements of any row or any columns in terms of delta are multiplied by k, so then it is called as delta 1. Then sixth one is, see if all the elements of any row or any column is a sum of 2 or more elements, then the determinant can be expand with the sum of 2 determinant. Then the single determinant can be expand with the sum of more terms of determinants. So what are the additions of their elements is depends on number of determinant is always depends on the how many elements are adding with their corresponding elements of in any rows or any column. So now will be prove on 2 different elements are adding with each other. A1 plus x, A2 plus y, A3 plus A2 plus y, A3 plus z like this. So any 2 elements are adding in all the elements of one of the row can be expand with the some 2 different determinants. 2 determinant agi expand ಮಾಡಬಹುದು. Again once we will recall. First one is if all the elements of rows and columns are interchanged, then the values of the determinants are does not altered. Second one is any 2 rows or any 2 columns are interchanged, then the values of the determinant are changes with the sign. Third one, if all the elements of any 2 rows or any 2 columns are identical, then the values of the determinant is 0. And fourth one is if all the elements of any row or any column is 0, then the determinant value is also 0. If all the elements of any rows are multiplied by some non-zero scalar number k, then the whole determinant is multiplied by k. And sixth one is if all the elements of any row or any column is a sum of 2 terms, after that it can be expanded with the sum of 2 determinants. These are the statement of the previous property. So today can be prove is another one of the property. Seventh one, prove that the values of the determinant is remains unchanged, means values of the determinant is does not altered if all the elements of any row or any column is multiplied by some scalar number k and adding the corresponding elements of any another row or columns. Now first we'll consider delta. Elements of delta are in the form of A1, A2, A3, B1, B2, B3, C1, C2, C3. That is not necessary, can be expansion of the delta values. So just will written as in the form of 3 cross 3 determinants. Then now to prove that if all the elements of any one of the row is multiplied by some non-zero scalar number k and these elements are adding with the corresponding elements of any another row or the column. Now first we will choosing for the elements of the second row are multiplied by k and these elements are adding with the corresponding element of either in first row or in the third row. Therefore, now we will be choosing for first row. So, R1 can be changes with R1 plus K times of R2. R1 can be changes with R1 plus K times of R2. It means if all the elements of R2 are multiplied by K and these elements are adding with the corresponding elements of R1. Therefore, delta can be written as, otherwise it is also denoted by delta 1 after some operations of their elements. So, delta 1 can be written as R1 is A1 plus K times of corresponding R2 is B1, that is A1 plus K times of B1. The next element is A2. A2 plus K times of corresponding element is B2. Then third one is A3 plus K times of B3. After then second and third rows are does not altered. B1, B2, B3, C1, C2, C3. Now to prove that what are the elements of delta 1 is always equal to delta. That is the one of the statement of the property. The values of the determinant is remain unchanged. So what are the elements of the delta is will be does not alter when all the elements of the any row or column is multiplied by k and these elements are adding with the corresponding elements of any another row or column. So by using the values of delta, now to prove that delta 1 is equal to delta. Now first we will consider the elements of delta 1 means LHS of the given proof. Now again prove ಮಾಡಬೇಕು ಅದರ left hand side na assume ಮಾಡ್ಕೊಳ್ಳಿ. Delta 1 is nothing but A1 plus KB1, A2 plus KB2, A3 plus KB3. Second rows are B1, B2, B3 and third row is C1, C2, C3. Then, but if it is also not necessary, by using the expansion of the determinants, we will already know that how can we expand the values of the determinant by using in their alternating sign. But in this property, these are not necessary. By using the statement of the previous property, if it is possible to get simplify. Now, if one of the property, so will be consider in the sixth property, if all the elements of any row or in any column is a sum of two elements, after that it can be expand with the sum of two determinants. So by using that property, by using sixth property, such a determinant can be expand with the sum of two determinants. But elements can be distributed. What are the elements are will be distributed in the first and the second determinant. In first determinants are A1, A2, A3 and second row is B1, B2, B3. Third row is also C1, C2, C3. Means second and third rows are does not altered in both of the determinants. Second and third rows are does not alter because these are not in the elements of addition or then subtraction, but only first row elements are either adding or subtraction with the some 2 or more elements. Therefore, these elements will be distributed, but second and third elements of rows of elements are always nothing but same. But in the first row, in the first determinant can be represented in the elements of A1, A2, A3. Similarly, in the second determinants contain their elements are KB1, KB2, KB3. Then, so after that in RHS, what are the elements of the first determinant? A1, A2, A3, B1, B2, B3, C1, C2, C3. R is nothing but delta or not. So, it is one of the elements of delta. Therefore, such a determinant can be written as delta. What are that? First determinants. Elements of the first determinant is nothing but delta. Therefore, the old terms can be denoted by delta. Plus, but it can be simplified in the second determinant. So, now the second determinant is K into B1, K into B2, K into B3, B1, B2, B3, C1, C2, C3. That is another one of the property. If all the elements of any row or any column is multiplied by some scalar number k, then the whole determinant is multiplied by k. It is one of the property for the fifth one. So, if all the elements of any row or any column is multiplied by some scalar number k, then the whole determinant is multiplied by k. Therefore, that k is possible to get a common factor by using the fifth property. By using fifth property. So, after that k as a common factor, it can be written as B1, B2, B3. Again second row is also B1, B2, B3. Third row is C1, C2, C3. So, all the elements of any row or any column is multiplied by k, then it can be written as k times of the remaining elements of delta by using the fifth property. So, after that, delta will be continue plus k times of. Then we will observe the elements of the determinants. First rows are B1, B2, B3, second row is B1, B2, B3, third row is C1, C2, C3. Therefore, the elements of the first and second rows are identical. Both the corresponding elements will be same. Therefore, the elements of first and second rows are identical. Therefore, by using the third properties of the determinants, if all the elements of any rows or columns are identical, then the values of the determinant will be 0. So, by using third property, so delta is nothing but 0. Therefore, delta plus k into 0, it will be equal to delta. So, it means delta 1 is equal to delta, that is the proof. So, therefore, it is an RHS. Then LHS is equal to RHS. It means the values of the determinant remains unchanged if all the elements of any rows or columns is multiplied by k, and these elements are adding or adding with the corresponding elements of any another row or columns. That is one of the property. So, next one, prove that if all the elements of one sides of the leading diagonal elements, now the leading diagonals are also called as principal diagonal elements, are 0, the values of the determinant is the product of the principal diagonal elements or leading diagonal elements, or just will be called as diagonal elements. Now, proof is, it is one of the most important property for your problems. Now, delta can be defined by, in generally elements are can be written as A1, A2, A3, B1, B2, B3, C1, C2, C3. These are the general elements of the determinant. But what are will be called as diagonal elements? A1, B2, C3 are called as principal diagonal elements or leading diagonal elements. Now, these three elements are called as upper triangular matrix and these are called as lower triangle. So, if any one of these two part r will be 0. Either it will be upper triangular or it will be lower triangular elements r will be 0. Now we will be consider for upper triangular elements of that matrix r will be 0. So that is called as one sides of the leading diagonal elements are 0 or principal diagonal elements are 0 or just will be called as diagonal elements are 0. Then the values of the determinant is the product of these three elements. Product of these three elements. Now it can be proved. So if it is can be expanded by using the alternating sign. So in the first row elements are a1 0 0, second row b1 b2 0, third one c1 c2 0. So by using the first row expand with the alternating sign. Now a1 is an element of first row first column and these elements are get neglected and the remaining are get cross multiplied by using the 2 cross 2 determinant. So left diagonals are b2 c3 minus c2 into 0. c2 into 0 is nothing but 0. Now the second element is 0 minus 0. 0 is an element of the first row second column. 0 is an element of first row second column and these elements are get neglected and remaining are get cross multiply. b1 c3 minus c1 into 0 is also 0. Now the third element is 0. 0 is an element of the first row third column and again these elements are get neglected and remaining are get cross multiply. That is b1 c2 minus c1 b2. After that, so b2 c3 minus 0 is nothing but b2 c3 into a1 is a1 b2 c3 minus 0 into anything will be. So that element is a multiple of 0. 0 into anything will be 0. Again 0 into anything will be 0. Therefore, the total element is b1, a1, b2, c3, that is the value of delta. But if these elements a1, b2, c3 are the elements of the principal diagonal elements, what are the product of these three elements is called the values of delta. So if any one sides of the leading diagonal elements are 0, then the values of the determinant is a product of the principal diagonal element. Suppose both sides of the diagonals are also 0, that is also will become same. So if any one of these side means if it is also possible to in both sides of the elements. So both sides of the diagonals are also 0, then the values of the determinant is called the product of the principal diagonal element. So these are the some basic properties of determinants. After that, by using this property, how to get simplify the problems and determinant without using their expansion, means without using in their alternating sign like these forms, how to get simplify the some problems on the basis of determinants. Problems on exercise 4.2. So using the properties of determinant and without expanding, that is the most important condition. Without expanding means it's not using in their alternating sign. In the given problems, it's not using in their alternating sign in the first steps. Some of their minimum 2 to 3 steps, after then will be using their alternating sign. So, ನೀವು ಮೊದಲನೇ ಕೇಸಸ್ಸಲ್ಲೇ ಪ್ಲಸ್ ಮೈನಸ್ ಪ್ಲಸ್ನ ಯೂಸ್ ಮಾಡಿ ಸಾಲ್ವ್ ಮಾಡೋಗಿಲ್ಲ. ಮಿನಿಮಮ್ 2 to 3 ಸ್ಟೆಪ್ಸ್ ಆದಮೇಲೆ ಇಫ್ ಇಟ್ ಈಸ್ ಪಾಸಿಬಲ್ ಟು ಗೆಟ್ ಎಕ್ಸ್ಪ್ಯಾಂಡ್ ಬೈ ಯೂಸಿಂಗ್ ದ alternating sign. But without expanding means by using the what are the 8 properties of the determinants. In any one of the property can be using that problems and solving how to get solution is nothing but 0. Now first we'll observe that properties of, and the first one is called as if the values of determinants are does not altered if the rows and columns are interchanged. If it is not usable for that properties in that cases, first one and second one, it's not necessary in all these problems, but third fourth will be possible some of their cases, some of the steps and the problems. So third one is nothing but If any two rows or any two columns are identical, then the values of the determinant is 0. So ನೋಡಿ ಎರಡು ಒಂದು minimum 2 steps ಆದಮೇಲೆ if it is possible to get the result in the form of identical, ಯಾವುದಾದ್ರು ಎರಡು 2 ರೋಸು ಅಥವಾ 2 ಕಾಲಮ್ಸು ಸೇಮ್ ಬರೋಂಥ ಚಾನ್ಸಸ್ ಇರುತ್ತೆ. ಸೊ ಆವಾಗ ನಾನು ಥರ್ಡ್ ಪ್ರಾಪರ್ಟಿನ ಯೂಸ್ ಮಾಡ್ಬೋದು. Similarly, fourth property, after some simplification, if all the elements are get cancelled, is nothing but 0, it's also possible. ಸೊ ಇಲ್ಲಿ ಫಸ್ಟು, ಸೆಕೆಂಡು, ಥರ್ಡು, ಫೋರ್ತು ನಿಮಗೆ ಡೈರೆಕ್ಟಾಗಿ ಪ್ರಾಬ್ಲಮಲ್ಲಿ ಫಸ್ಟು ಸ್ಟೆಪ್ಸ್ ಎಲ್ಲ ಯೂಸ್ ಆಗಲ್ಲ. ಸೊ ದೇರ್ಫೋರ್ ಫಸ್ಟ್ ವಿಲ್ ಕಮ್ ಟು ದ ಫಿಫ್ತ್ ಪ್ರಾಪರ್ಟಿ. Now fifth properties means if all the elements of any row or column is a multiple of any some scalar number. ನೀವು ಯಾವುದೇ ಪ್ರಾಬ್ಲಮ್ಸನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರು ಫಸ್ಟ್ ವಿಲ್ ಚೆಕ್ ಔಟ್ ದಿ ಫಿಫ್ತ್ ಪ್ರಾಪರ್ಟಿ. So if all the elements of any row or in any column, it's possible to get an any multiple numbers or any common factor. So first adana check ಮಾಡಿ. Otherwise in the first ನಲ್ಲಿ x a x plus a, if you have any common factor y b y plus b, z c z plus c, ಇದು ಯಾವುದಾದ್ರು ಕಾಮನ್ ಫ್ಯಾಕ್ಟರ್ಸ್ ಅಲ್ಲಿ ನಮಗೆ. ಸೊ ಇಟ್ಸ್ ನಥಿಂಗ್. ಸೊ ದೇರ್ಫೋರ್ so get adding. Next condition is any two rows or any two columns are adding with each other or subtracting with each other after if it is possible to get a common factors. ನೀವು ಯಾವುದಾದ್ರು ರೋಸ್ಗಳನ್ನ ಅಥವಾ ಕಾಲಮ್ಸ್ನ ಆ್ಯಡ್ ಮಾಡಿದ್ಮೇಲೆ ಐದರ್ ಕಾಮನ್ ಫ್ಯಾಕ್ಟರ್ಸ್ ಆಗಿರ್ಬೋದು, ಅದರ್ವೈಸ್ ಐಡೆಂಟಿಕಲ್ ಆಗಿರ್ಬೋದು, ಅದರ್ವೈಸ್ ಝೀರೋ ಫಾರ್ಮೇಷನ್ಗೆ ಬರೋಂಥ ಕೇಸಸ್ ಇರುತ್ತೆ. ಫಸ್ಟ್ ವಿಲ್ ಚೆಕ್ ವೆದರ್. ಸೊ ನಾವು ಫಸ್ಟ್ ವಿಲ್ ಅಬ್ಸರ್ವಿಂಗ್ ಇನ್ ದೀಸ್ ಟು ಎಲಿಮೆಂಟ್ಸ್. First and second column. First column is x, second column is a. After addition is nothing but x plus a. That is another elements of the third column. Similarly y and b, z and then c. Therefore, now c1 can be changes with c1 plus c2. Elements of c1 and c2 are get adding with each other, and if it is changes with their elements of place of c1 in a place ಅಲ್ಲಿ change ಮಾಡಿ, that is an addition of corresponding elements of c1 and c2. First one x plus a, second element y plus b, third element z plus c. After that, what are the elements of the second column and third columns are does not alter. Now will applied for only for the first column. ನಾನೀಗ ಚೇಂಜಸ್ ಮಾಡ್ತಾ ಇರೋದು ಓನ್ಲಿ ಫಾರ್ ದಿ ಫಸ್ಟ್ ಕಾಲಮ್. ವಾಟ್ ಆರ್ ದಿ ಎಲಿಮೆಂಟ್ಸ್ ಆಫ್ c1 and c2 ಆರ್ ಆ್ಯಡಿಂಗ್ ವಿತ್ ಈಚ್ ಅದರ್, ಆ್ಯಂಡ್ ದೀಸ್ ಎಲಿಮೆಂಟ್ಸ್ ಆರ್ ಕ್ಯಾನ್ ಬಿ ಇನ್ಸ್ಟೆಡ್ ಇನ್ ಪ್ಲೇಸ್ ಆಫ್ c1. ಸೊ ಆಫ್ಟರ್ ದಟ್ ಸೆಕೆಂಡ್ ಆ್ಯಂಡ್ ಥರ್ಡ್ ರೋಸ್ ಕಾಲಮ್ಸ್ನ ಆ್ಯಸ್ ಇಟ್ ಈಸ್ ನಾನು ಹಾಗೆ ಕಂಟಿನ್ಯೂ ಮಾಡ್ತಾ ಹೋಗಿದ್ದೀನಿ. So then we'll observe their elements of first column, second column and third column. So if it is possible to apply in any one of the properties. So that is first and third columns are identical formation. Yamanta nodi corresponding elements are will be equal. X plus a, y plus b, y plus b, z plus c, z plus c. Therefore all the elements of c1 and c3 are identical. c1 and c3 are identical. Therefore the values of delta is nothing but 0. So therefore elements of first and third columns are 0. Therefore by using the third property, then the values of the determinant will be 0. That 0 is one of the solution. So that is the procedure. So again once we'll observe. So first we'll in our LHS is generally called as delta or determinants. ಯಾವುದ್ರಲ್ಲಾದ್ರು ಯೂಸ್ ಮಾಡಿ. ಸೊ ಫಸ್ಟ್ ವಿಲ್ ಅಬ್ಸರ್ವ್ ನೋಡಿ, ಫಸ್ಟ್ ಪ್ರಾಪರ್ಟಿ ಸೆಕೆಂಡ್ ಪ್ರಾಪರ್ಟಿನ ನೀವು ಡೈರೆಕ್ಟಾಗಿ ಎಲ್ಲೂ ಯೂಸ್ ಮಾಡಲಿಕ್ಕಾಗಲ್ಲ. ಥರ್ಡ್ ಆ್ಯಂಡ್ ಫೋರ್ತ್ ಏನಿರುತ್ತೆ ಇಸ್ ಡಿಪೆಂಡ್ಸ್ ಆನ್ ಸಮ್ ಆರ್ ಟು ಆರ್ ಮೋರ್ ಸ್ಟೆಪ್ಸ್ ಆಫ್ಟರ್ ದ ಸಿಂಪ್ಲಿಫಿಕೇಷನ್. ಥರ್ಡು ಫೋರ್ತೂ ಪ್ರಾಬ್ಲಮಲ್ಲಿ ಆ್ಯಸ್ ಇಟ್ ಈಸ್ ಡೈರೆಕ್ಟಾಗಿ ಇರಲ್ಲ. ಸೊ ಹಾಗಾಗಿ ಫಿಫ್ತ್ ಪ್ರಾಪರ್ಟಿಯಿಂದ ಶುರು ಮಾಡ್ಕೊಳ್ತಾ ಹೋಗಿ. ಸೊ ಫಸ್ಟ್ ವಿಲ್ ಅಬ್ಸರ್ವ್ ದ ಫಿಫ್ತ್ ಪ್ರಾಪರ್ಟಿ. ಇಫ್ ಆಲ್ ದಿ ಎಲಿಮೆಂಟ್ಸ್ ಆಫ್ any row or any column is a multiple of some scalar number. ಯಾವುದಾದ್ರು ರೋನಲ್ಲಿ ಅಥವಾ ಕಾಲಮ್ಸಲ್ಲಿ ಸಮ್ ಸ್ಕೇಲಾರ್ ನಂಬರ್ಸು ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್ ಫಾರ್ಮೆಟಲ್ಲಿ ಇದೆಯಾ ಚೆಕ್ ಮಾಡಿ. ಸೊ ಐದರ್ ಇನ್ ರೋ ವೈಸ್ ಆರ್ ಇನ್ ದರ್ ಕಾಲಮ್ ವೈಸ್. ಬಟ್ ಈ ಪ್ರಾಬ್ಲಮ್ಸಲ್ಲಿ ಎನಿ ಎಲಿಮೆಂಟ್ಸ್ ಆರ್ ನಾಟ್ ಇನ್ ದಿ ಫಾರ್ಮ್ ಆಫ್ ಮಲ್ಟಿಪಲ್. ಹಾಗೆ ಫಿಫ್ತ್ ಪ್ರಾಪರ್ಟಿ ಈಸ್ ಆಲ್ಸೋ ನಾಟ್ ಅಪ್ಲಿಕಬಲ್ ಇನ್ ದ ಡೈರೆಕ್ಟ್ ವೇಸ್. ಸೊ therefore get next condition is either adding or subtracting of any rows or the columns. ನೀವು ಯಾವ್ದಾದ್ರು ರೋನ ಅಥವಾ ಕಾಲಮ್ಸ್ನ ಐದರ್ ಅಡಿಷನ್ ಆರ್ ದೆನ್ ಸಬ್ಟ್ರಾಕ್ಷನ್ ಮಾಡಿದ್ರೆ ಸೊ ಇಟ್ ವಿಲ್ ಬಿ ಐದರ್ ಐಡೆಂಟಿಕಲ್ ಆರ್ ಇಟ್ ವಿಲ್ ಬಿ ಝೀರೋ. ಸೊ ಕ್ಯಾನ್ಸಲ್ ಆಗಿ ಝೀರೋ ಬರೋ ಚಾನ್ಸಸ್ ಇರುತ್ತೆ ಅಥವಾ ಐಡೆಂಟಿಕಲ್ ಸೇಮ್ ಫಾರ್ಮೇಷನಲ್ಲಿ ಎಲಿಮೆಂಟ್ಸ್ ಬರೋಂಥ ಚಾನ್ಸಸ್ ಇರುತ್ತೆ. ಸೊ therefore now get adding C1 and C2 elements of first column and second columns are adding with each other, and these additions are replaced in their elements of C1. Therefore C1 can be changes with C1 plus C2. So corresponding elements are get adding x plus a, y plus b, z plus c. These are the elements of the first column. Second and third columns are nothing but same. So after then we will observe the elements of the first and third column. First column ಮತ್ತು third column elements na observe ಮಾಡಿ. If all these elements are will be identical, same formation ಗೆ ಬಂತ ನೋಡಿ ಇಲ್ಲಿ x plus a, y plus b, z plus c. Therefore all the elements of C1 and C3 are identical. By using the third property, then the values of the determinant will be 0. Therefore delta is equal to 0. It's an RHS. That is the first one. So similarly second problem is to prove that determinant of a minus b, b minus c, c minus a. Second row is b minus c, c minus a minus b. Third row a minus b, b minus a minus b and b minus c. Now again we will observe from the fifth property. So ಇವಾಗೂ ಅಷ್ಟೇ ಫಿಫ್ತ್ ಪ್ರಾಪರ್ಟಿಯಿಂದ ಅದನ್ನು ಅಬ್ಸರ್ವ್ ಮಾಡಿ. ಇಫ್ ಇಟ್ ಈಸ್ ಪಾಸಿಬಲ್ ಟು ಗೆಟ್ ಎನಿ ಕಾಮನ್ ಫ್ಯಾಕ್ಟರ್ಸ್ ಫ್ರಾಮ್ ಎನಿ ರೋಸಸ್ ಆರ್ ಎನಿ ಕಾಲಮ್ಸ್. ನೀವು ಯಾವುದೋ ಒಂದು ರೋನಲ್ಲಿ ಅಥವಾ ಒಂದು ಕಾಲಮ್ಸಲ್ಲಿ ಎನಿ ಕಾಮನ್ ಫ್ಯಾಕ್ಟರ್ಸ್ ಇದೆಯಾ ಅನ್ನೋದನ್ನ ಅಬ್ಸರ್ವ್ ಮಾಡಿ. ಸೊ ಇದರಲ್ಲಿ ಯಾವುದೋ ಕಾಮನ್ ಫ್ಯಾಕ್ಟರ್ಸ್ ಇಲ್ಲ. therefore it's again by using the previous property, so previous condition, get be adding or subtracting the some corresponding elements of any rows or column if it is possible to form of identical, otherwise it will be 0. But ಇಲ್ಲಿ maximum elements are in the form of addition and subtraction, plus minus ಅಲ್ಲಿ ಇರೋದ್ರಿಂದ so both are will be exist in case of addition and then subtraction. Therefore if it is possible to get cancel, so cancel ಮಾಡಬೇಕು ಅಂದರೆ ಯಾವುದನ್ನ ಆ್ಯಡ್ ಮಾಡಬೇಕು ನೋಡಿ. If these are the elements of the first row, suppose if these elements are get adding with each other, a minus b plus b minus c plus c minus a. After that addition, if all their elements are get cancelled or not, so plus a minus b plus b minus c plus. So if all these elements are get cancelled, is nothing but 0. So similarly for the elements of second row, b minus c plus c minus a plus a minus b. So plus b minus b are get cancelled, minus c plus c are get cancelled, minus a plus a are get cancelled. So again if it is nothing but 0. So similarly for the third column, so third column is a minus c minus a plus a minus b plus b minus c, again plus c minus c minus a plus a minus b plus. So if it is possible to get adding if the corresponding elements of row wise. Similarly for the column, again once we'll check whether in their column formation. But if these elements are also get adding with each other, plus a minus b plus b minus c plus c, these are also nothing but 0. Similarly plus b minus c plus c minus a plus a, these are also 0. c minus c, a minus a, b minus b. ಸೊ ಅಲ್ಲಿಗೆ ಈ ಪ್ರಾಬ್ಲಮಲ್ಲಿ ನಾನು ರೋ ವೈಸ್ ಆ್ಯಡ್ ಮಾಡಿದ್ರೂ ಕ್ಯಾನ್ಸಲ್ ಆಗ್ತಾ ಇದೆ, ಕಾಲಮ್ ವೈಸಲ್ಲಿ ಆ್ಯಡ್ ಮಾಡಿದ್ರೂ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. ಸೊ therefore ವಿಲ್ ಬಿ ಚೂಸಿಂಗ್ ಫಾರ್ ಐದರ್ ಇನ್ ರೋ ಅಡಿಷನ್ ಆರ್ ದೆನ್ ಕಾಲಮ್ ಅಡಿಷನ್. Suppose we'll get adding like this, these elements are get adding with each other, now can be operated in the form of row wise. ನೋಡಿ ಈಗ ನಿಮಗೆ ಇಲ್ಲಿ ಕಾಲಮ್ ವೈಸ್ ಆ್ಯಡ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಅಂದರೆ ರೋ ಯಾಕೆ ಚೇಂಜ್ ಮಾಡ್ತೀನಿ ನಾನು. So if these are the corresponding elements of corresponding elements of first row, second row and third row. So that is A minus B is the first element of the first row, B minus C is the first element of the second row and C minus A is the first element of the third row. So if all these are represented in place of first place of different rows. So ಎಲ್ಲ ರೋಸಸ್ಗಳನ್ನು ಅದು ಫಸ್ಟ್ ಪ್ಲೇಸ್ ಅಂತ ಕನ್ಸಿಡರೇಷನ್ ಆಗ್ತಾರಲ್ಲ, ದಟ್ ಈಸ್ ದೀಸ್ ಆರ್ ವಿಲ್ ಬಿ ಕಾಲ್ಡ್ ಆಸ್ ಕರೆಸ್ಪಾಂಡಿಂಗ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಫಸ್ಟ್ ಎಲಿಮೆಂಟ್ ಆಫ್ ಫಸ್ಟ್ ರೋ, ಫಸ್ಟ್ ಎಲಿಮೆಂಟ್ ಆಫ್ ಸೆಕೆಂಡ್ ರೋ, ಫಸ್ಟ್ ಎಲಿಮೆಂಟ್ ಆಫ್ ದಿ ಥರ್ಡ್ ರೋ. Therefore these are adding with each other. R1 can be changes with R1 plus R2 plus R3. ಸೊ ನಾನೀಗ ಆ್ಯಡ್ ಮಾಡ್ತಾ ಇರೋದು ಕಾಲಮ್ ವೈಸಲ್ಲಿ, ಬಟ್ ಆಪ್ರೇಟ್ ಆಗ್ತಾ ಇರೋದು ರೋ ವೈಸಲ್ಲಿ. ಸಪೋಸ್ ಇಫ್ ಇಟ್ ಈಸ್ ಆ್ಯಡಿಂಗ್ ಇನ್ ದಿ ಫಾರ್ಮ್ ಆಫ್ ರೋ ವೈಸ್, ನನಗೆ ರೋ ವೈಸ್ನೇ ಆ್ಯಡ್ ಮಾಡಿದ್ರೆ, ಇಫ್ ದೀಸ್ 3 ಎಲಿಮೆಂಟ್ಸ್ ಆರ್ ದಿ ಕರೆಸ್ಪಾಂಡಿಂಗ್ ಎಲಿಮೆಂಟ್ ಆಫ್ ದಿ ಕಾಲಮ್ಸ್. Now A minus B is the first element of the first column, B minus C is the first element of the second column and C minus A is the first element of the third column. So ನಾನು ರೋ ವೈಸ್ ಆ್ಯಡ್ ಮಾಡಿದ್ರೆ ಕಾಲಮ್ ವೈಸ್ ಆಪ್ರೇಟ್ ಮಾಡಬೇಕು, ಕಾಲಮ್ ವೈಸಲ್ಲಿ ಆ್ಯಡ್ ಮಾಡಿದ್ರೆ ರೋ ವೈಸಲ್ಲಿ ಆಪ್ರೇಟ್ ಮಾಡಿ. ಸೊ ಈಗ ರೋ ವೈಸಲ್ಲಿ ಆಪ್ರೇಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಅಂದರೆ ನಾವು ಗೆಟ್ ಆ್ಯಡಿಂಗ್ ವಿತ್ ದ ಕಾಲಮ್ ವೈಸ್. ಸೊ therefore in the elements of the first row, first element A minus B plus first element of the second row B minus C plus first element of the third row is nothing but C minus A. Similarly, R1 changes to R1 plus R2 plus R3. In the first row, first element of the first row is A minus B plus first element of the second row is B minus C plus first element of the third row is C minus A. Similarly, corresponding elements of the second places, B minus C is called as second element of the first row, C minus A is also second element of the second row and A minus B is second element of the third row, and these elements are get adding with each other. B minus C plus C minus A plus A minus B. Similarly, third column. So if these are the corresponding elements of the third place, C minus A is the third element of the first row, A minus B is the third element of the second row and B minus C is the third element of the third row. Now these are also get adding. C minus A plus A minus B plus B minus C. Then the remaining elements of second and third rows are nothing changes. Does not alter for the elements of the second and the third row. Both are will be continuing in the same form. So after then we'll get simplified. In the first row, plus A minus A minus B plus B minus C plus C. So if all these elements are get cancelled, therefore the elements of the first row is nothing but 0. Similarly, second element plus B minus B minus C plus C minus A plus C. Again all those elements are get cancelled is 0. Then third one is minus plus C minus C minus A plus A and plus B minus B. So those are also get cancelled, but remaining rows are will be same. B minus C, C minus A minus B, C minus A minus B, B minus C. So after then by using the properties, if all the elements of the first rows are 0, all the elements of R1 is 0. Therefore, delta is nothing but 0 by using the fourth property. If all the elements of any row or any columns are 0, then the values of the determinant is nothing but 0. It's one of the properties of the determinant. So that is called as an RHS. That is the solution. So again once we'll observe that if all the elements of any row or any column, first we'll check whether ಸೊ ಆಫ್ಟರ್ ದೆನ್ ರೈಟಿಂಗ್ ದ ಕಂಡೀಷನ್ಸ್ ಆಫ್ ನೋಡಿ, ನೀವು ಯಾವುದೇ ಪ್ರಾಬ್ಲಮ್ಸ್ ಆದರೂ ಮೊದಲೊಂದು ಸಲ ಚೆಕ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಫಸ್ಟ್ ವಿಲ್ ಫಿಫ್ತ್ ಪ್ರಾಪರ್ಟಿ ಇಫ್ ಇಟ್ ಈಸ್ ಪಾಸಿಬಲ್ ಟು ಎನಿ ಕಾಮನ್ ಫ್ಯಾಕ್ಟರ್. ಸೊ ಯಾವುದಾದ್ರು ಒಂದು ಕಾಮನ್ ಫ್ಯಾಕ್ಟರ್ಸು ಮಲ್ಟಿಪಲ್ ಫಾರ್ಮೇಷನಲ್ಲಿ ಇದೆಯಾ ಚೆಕ್ ಮಾಡಿ. ಆಫ್ಟರ್ ದೆನ್ ಬೈ ಯೂಸಿಂಗ್ ಐದರ್ ಅಡಿಷನ್ ಆರ್ ದೆನ್ ಸಬ್ಟ್ರಾಕ್ಷನ್. ಈಗ ಲಾಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್ ಥರ ಎನಿ ಟು ರೋಸ್ ಆರ್ ಎನಿ ಟು ಕಾಲಮ್ಸ್ನ ಆ್ಯಡ್ ಮಾಡಿದ್ರೆ ಕಾಮನ್ ಬರುತ್ತಾ ಚೆಕ್ ಮಾಡಿ. ಅದರ್ವೈಸ್ ಬೈ ಯೂಸಿಂಗ್ ದ ಸಬ್ಟ್ರಾಕ್ಷನ್ ಇಫ್ ಇಟ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ 0. ಬಟ್ ಆಪ್ರೇಟ್ ಮಾಡಬೇಕಾದ್ರೆ ನೀವು ರೋ ವೈಸ್ ಆ್ಯಡ್ ಮಾಡಿದ್ರೆ ಕಾಲಮ್ ಚೇಂಜ್ ಮಾಡಿ, ಕಾಲಮ್ ವೈಸ್ ಆ್ಯಡ್ ಮಾಡಿದ್ರೆ ರೋ ಚೇಂಜಸ್ ಮಾಡಿ. ಸೊ ಇಫ್ ದೀಸ್ ಎಲಿಮೆಂಟ್ಸ್ ಆರ್ ದಿ ಕರೆಸ್ಪಾಂಡಿಂಗ್ ಎಲಿಮೆಂಟ್ಸ್ ಆಫ್ R1, ಸೊ ಆಪ್ರೇಟಿಂಗ್ ವಿತ್ ದ ಕಾಲಮ್ ವೈಸ್. ಸೊ ಅದರ್ವೈಸ್ ಕರೆಸ್ಪಾಂಡಿಂಗ್ ಎಲಿಮೆಂಟ್ಸ್ ಆಫ್ ಇನ್ ಕಾಲಮ್ ಆ್ಯಡಿಂಗ್ ವಿತ್ ದ ರೋ ವೈಸ್. ದೀಸ್ ಆರ್ ದಿ ಆಪೋಸಿಟ್ ಕಂಡೀಷನ್. ಸೊ R1, R2, R3 ಆ್ಯಡ್ ಮಾಡ್ತಿದ್ವಿ ಅಂದರೆ ದೀಸ್ ಆರ್ ದಿ ಎಲಿಮೆಂಟ್ಸ್ ಆಫ್ ದಿ ಕಾಲಮ್ ಫಾರ್ಮೇಷನ್. ಸೊ ದಟ್ ಈಸ್ ಸಮ್ ಪ್ರಾಬ್ಲಮ್ಸ್. Next one, prove that 1 BC A of B plus C, 1 CA B of C plus A, 1 AB C of A plus B equal to 0. Now again we will be considering the LHS, otherwise it's also denoted by delta. Again by using the fifth properties of determinant, if it is possible to any common factors for any rows or any columns. And in the first column, first row, 1 BC A of B plus C. So its first element is 1, therefore it's not any multiple elements, therefore does not have any common factor. So therefore the fifth property is not applicable in the direct form. So therefore by using the either addition or then subtraction. But once we'll observe the elements of the third column, if all elements is one of the form of distributive, therefore first we'll get distributive these elements. 1 1 1 BC CA AB, and these elements can be distributed AB plus AC. Second element is BC plus BA or AB, and third element is CA plus C. First will once will distributive properties can be applicable on the elements of the third column. After that, so you will get adding these elements. So one of the elements is AB plus BC and AC. The same types of elements are also represented in the remaining two or not? ನೋಡಿ ಇಲ್ಲಿ ಎ ಬಿ ಇದೆ, ಬಿ ಸಿ ಇದೆ, ಎ ಸಿ ಇದೆ ಅಂದಮೇಲೆ ಸೆಕೆಂಡ್ ಆ್ಯಂಡ್ ಥರ್ಡ್ ಪ್ಲೇಸಲ್ಲೂ ಸೇಮ್ ಎಲಿಮೆಂಟ್ಸ್ ಇರುತ್ತೆ ನೋಡಿ. ಇಲ್ಲಿ ಎ ಬಿ ಬಿ ಸಿ ಎ ಸಿ, ಅಗೇನ್ ಎ ಬಿ ಬಿ ಸಿ ಎ ಸಿ. ದೇರ್ಫೋರ್ R3 can be changes with C3 can be changes with C3 plus C2. Elements of third and second columns are adding with each other, and instead of third columns are will be replaced. Elements of first columns are same, second columns is also nothing but same. Now it can be operate only for the third column. First columns are 1 1 1, second columns are B C C A and then A B. Third column is nothing but sum of second and the third column. Second and third columns are nothing but A B plus B C plus C A. Similarly, if these elements are A B plus B C plus C A, third elements are A B plus B C plus C A. So then we'll observe all the elements of the third columns are nothing but same or different. But if all the elements are nothing but same, A B B C C A, A B B C C A, A B B C C. So then we'll by using the fifth properties of determinants, if it is possible to get a common factor. Therefore, these elements as a common factor, A B B C plus C A as a common factor. So what about the remaining? In first column is 1 1 1, second column is B C, C A and then A B. So after common factors of these elements, then the third column is also nothing but 1 1 1. So for properties of determinant, if all the elements of any rows or any column is a multiple of some scalar number, so whole determinant is multiplied by k. It means if any row or any column is a multiple number, if it is easily get a common factor from that row. So ನಮಗೆ ಈ ರೋನಲ್ಲಿ ಇದು ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್ ಫಾರ್ಮೆಟಲ್ಲಿ ಇಲ್ಲ, ಇದರ ಅಡಿಷನಲ್ಲಿ ಇದೆ. But if each elements are also can be called as multiple of 1. If every element is always a multiple of 1. ಹಾಗಾಗಿ ಎ ಬಿ ಪ್ಲಸ್ ಬಿ ಸಿ ಪ್ಲಸ್ ಸಿ ಎ ಕಾಮನ್ ತೆಗೆದ್ರೆ ಆಫ್ಟರ್ ದಟ್ ಪ್ಲೇಸಸ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ 1. ಸೊ ಆಫ್ಟರ್ ದೆನ್ ವಿಲ್ ಅಬ್ಸರ್ವ್ ಆಲ್ ದಿ ಎಲಿಮೆಂಟ್ಸ್ elements of first and third column. So first and third columns are nothing but identical. Therefore C1 and C3 are identical. Then the values of the determinant is nothing but 0. So if it is nothing but 0 into any multiple number, values of the determinant is 0 into AB plus BC plus CA is also 0. Therefore the delta is nothing but 0. It's an RHS. So similarly the next one is prove that some numerical value 8, 2, 7, 12, 3, 5, 16, 4, 3 is equal to 0. Now first we will consider in the delta. 8, 2, 7, 12, 3, 5, 16, 4, 3. So first we will observe if all the elements of any rows or any columns is a multiple of some number. So multiple means if it is possible to get any common factors. ನೀವು ಯಾವ್ದಾದ್ರು ಒಂದು ರೋನಲ್ಲಿ ಅಥವಾ ಒಂದು ಕಾಲಮ್ಸಲ್ಲಿ ಕಾಮನ್ ತೆಗಿಲಿಕ್ಕಾಗತ್ತಾ ನೋಡಿ. And in first row 8, 2 and 7. Now but 8 and 2 is possible to get a common factor. Both are will be called as multiple of 2. But 7 is not a multiple. So therefore it's not possible. Similarly for the second row 12, 3, 5. So any common factor? No. That because 5 and 3 are not a multiple of any numbers. 16, 4, 3. Again 3 is not a multiple of. Similarly we'll observe the elements of the first column. 8, 12, 16. Now get possible to any common factor because 8 can be written as 8 it's a multiple of 4 and 2. 8 can be written as 4 into 2. 2 and 7 are will be continue. Similarly 12 can be written as, so 12 is nothing but 4 into 3. 4 into 3 and second elements are 3 and 5 are will be continue. So similarly for the third row 16 can be written as 4 into 4. Remaining two elements are 4 and 3. So then we'll observe if all the elements of the first column it's a multiple of 4. So therefore that 4 has a common factor by using the fifth property. So 4 has a common factor by using the fifth property. After that 2, 3, 4 are will be remaining. Similarly second column is 2, 3, 4 and third column is 7, 5, 3. So then we'll observe if all the elements of the first and second columns are identical or not. So 2, 2, 3, 3, 4, 4 both are will be identical. Therefore C1 and C2 are identical. C1 and C2 are identical. Therefore the values of delta is nothing but 0. So by using the third property, if all the elements of any two rows or any two columns are identical, then the values of the determinant is 0. Next one. Prove that 42, 16, 28, 7, 4, 14, 3, 2 is equal to 0. Now again once we'll check whether whatever are called as delta, otherwise in the LHS. If any rows or any columns are is a multiples or not. Observe ಮಾಡಿ ಒಂದ್ಸಲ. Elements are 42, 16, 28, 7, 4, 14, 3, 2. So if you observe the elements of the first column, because second and first rows are not a multiple of any numbers. One idare ಇದೆ, second row ನಲ್ಲಿ 7 ಇದೆ, it's not a multiple of numbers. Third row ನಲ್ಲಿ 3 ಇರೋದ್ರಿಂದ again it's not a multiple of any other numbers. Therefore we'll observe the elements of the first column. So 42, 28 and 17 are the multiples of 7. Therefore 42 can be written as 7 into 6. 28 can be written as 7 into 4 and 14 can be written as 7 into 2. In the second row, second column is 1, 7, 3. Third column is 6, 4, 2. After that, all the elements of the first column, it's a multiple of 7. Therefore, 7 as a common factor by using the fifth property. If all the elements of any rows or any column is a multiple of some scalar number, then their whole determinant is a multiple of k. Therefore, 7 as a common factor. Remaining elements are 6, 4, 2, 1, 7, 3, 6, 4, 2. So, then we will observe if the elements of the first and third column 6, 6, 4, 4, 2, 2. If all the elements of C1 and C3 are identical. C1 and C3 are identical. Therefore, the values of delta is equal to 0 by using the third properties of the determinant. Similarly, next one is 2, 7, 65, 3, 8, 75, 4, 9, 86. So, first once we'll observe their elements. At 65, 75, 86 is any multiple numbers. Now, 65 can be written as 13 5s, 75 can be written as 15 something. But 86 is not a multiple of 5. Therefore, so first we'll get subtraction of these elements. Now, C3 can be changes with C3 minus C1. So, first column is 2, 3, 5. Second column is 7, 8, 9. But in the third column is C3 minus C1. 65 minus 2 is 63. Second element is 75 minus 3 is 72. And third one is 86 minus 5 is 81. So, get subtraction of C3 and then C1. After that, C3 is a multiple of first column, second column does not alter, but C3 can be written as 63 can be written as 9 into 7. 63 can be written as 9 into 7. 72 can be written as 9 into 8. 72 is 9 into 8. Again, 81 can be written as 9 into 9. Therefore, if all the elements of the third column is a multiple of 9, therefore, by using the fifth property, that 9 as a common factor. So, after that 2, 7, 7. So, 3, 8, 8. 5, 9, 9. So, then we will observe the elements of the second column and then third columns will be identical. Therefore, C1, C2 and C3 are identical. C2 and C3 are identical. Therefore, the values of delta is nothing but 0, that is under RHS.